Hello everyone, welcome back to the channel. So let us discuss the next problem from our binary search tree today, which is lowest common ancestor of a BST. So this question I'm assuming you must have solved in binary trees. Even if not to worry. But yes, I would suggest that you solve that for binary trees as well, and today we will be doing it for BST. Let me just check if we are live. Let me meanwhile show you the problem statement. Okay, to check the solution right now. Yes, so have a look. What we need to do here is that given a binary search tree with all unique values, the two nodes n1 and n2 are given. You have to find the lowest common ancestors of the two nodes in a BST. So for this, let's move to the board. Let me draw a tree like this, which is, for example, 5, 4, 6, 7, 8. And we have 3. For example, it's given you have to find lowest common ancestor of 7, 8. I'll take some better examples to help you understand if you do not know what is LCA. So lowest common is, by this we mean that what will be the nearest node for which these two nodes will be the descendants. Okay, try to understand it in this way. And the node itself can also be the LCA. That means if we check for 7 and 8, I know that 8 is a descendant of 7, so I can consider 7 itself as LCA. If I ask you what will be the, let me take extend this example. For example, if I give you like this 10, okay, this should be greater than 5, 4 and 5, nothing can go here. Let's take other example. Let me take some BST example. Okay, so if I take a tree like this, I have 8, 3, 10, 1, 6. Why I am taking an example from, because we have to take care that it follows the property of a BST. So I cannot just randomly draw it. It will take some time to see what all nodes I can insert in the left and right. So this is the reason. Let me check. Okay, so for example, this is your tree and you are given what is the LCA of, let's say I am giving you, tell me what will be the LCA of 4 and 1. Okay, suppose n1 is 4, n2 is 1. So you will check what is the nearest parent such that 4 and 1 will be the descendants of both. So what are the possibilities? For example, there is some node, okay, which has 4 probably on its right. In how many branches we don't know, maybe there's one n2 here and then we have 4 present here, for example, then 1 is present directly here. So in that case this will act as a LCA for this. If we check here, you see that this is 1, this is 4. If I go above, I see 6. 1 is not the descendant of 6, so we'll have to go further up. I can see that 3 is that nearest node from both of them such that both of them are descendants of 3. So LCA will be 3 in that case. If I ask you what will be the LCA of 13 and 10, okay, so this is your 13 and this is your 10. You can see that in this case both are coming on the right of 8. But will I say 8 is my LCA? Because obviously both are towards both are the descendants of 8, but I have to see which is the lowest common ancestor. So if the node itself happens to be one of them, we can consider it as an LCA. So in this case 10 will be an LCA. So this was a little bit diving into LCA if in case you have not seen this before. Okay, now the thing is, how are we going to solve this problem? So in order to understand this, you need to understand the scenarios. So what could be the possible scenarios, guys? See, you are given a node n1, you are given a node n2. There are possibilities that this n1 and n2 lies on the left and right of some node. Let's say this is your parent node. Let me take some. This is your parent node, okay, and somewhere in the left n1 comes and somewhere in the right n2 comes. In that case, for example, if this is the root node, I will return root, right, that this is your LCA. And if I talk about other scenario, the other scenario could be that both of them lie in the left of the root node. Okay, so for example, if I talk about 1 and 3, So I will check the root. I'll see that both the nodes 1 and 3 both are smaller than 8. So I will go and check it in the left subtree of 8, right? Then I come at 3. I see that it is one of the nodes that I am checking. So in that case, I will directly return this value, right? So I am returning the root for that recursion that I am trying to make, okay? Other cases, for example, both the nodes n1 and n2 are greater than the root node that I am trying to search for. For example, I am trying to check it for 13 and 14. 13 and 14. In this scenario, you will go, let me just delete it. Okay, so what are you doing? You check the root node. You check n1 and n2 are greater than 8. So one thing is for sure that it is going to lie somewhere in the right of 8 because it's a BST and it will follow that property of a binary search tree. So I go to the next right node of 8, which is 10. I check that still both the nodes are greater than this node, and obviously 10 is not one of them. So I go further. I know that I am going to find it in the right of 10. Okay, so I go, then I land at 14. I realize that it is one of the nodes that I was searching for. So I return this root value, root.data. Getting my point? So what did we see so far? The two scenarios were when both the nodes were less than the root value, and that root value can correspond to any of the subtree that I am recursively checking for. So in that case, actually I am making recursive calls to the root dot left until I find one of them as the root, right? Root for that subsequent recursive call. Same thing, other scenarios, when I see that both the nodes are greater than my current root, I go and traverse the right subtree and do that recursively until I get the root value equal to one of them. Other scenario is that one of them lies in the left side and other one lies in the right side. So for example, if I consider a scenario like this, let me take it 1 and 4. Okay, so for example, you have 1 and 4. I go to root. Okay, I go to root. I see that 1 and 4, both of them are less than 8. Okay, so I'm going to get it somewhere in the left of 8. I recursively check for the left subtree in which 3 is my current root. I see that 1 is less than 3 but 4 is greater than 3. So the moment I realize that this condition is not holding true, what condition? Neither this condition is holding true, okay, nor this condition is holding true. And what were these conditions? The first scenario that we were checking was that both the nodes were less than the root value, and other one was both the nodes were greater than my root value. So it is not lying in any of these two conditions. So clearly it means that they are splitting. Now is when this is the node from where I will see that one of the nodes might come in its left part and one of the nodes might come in its right part. We don't know still at which node I am going to get, but this is the point of diversion. The moment I get this, the moment I realize that none of these two conditions are holding true, I will return directly root data from here itself. I'm not root data, root itself, that your function itself will return the data. But the moment I realize that none of these conditions are holding true, it automatically goes to the third condition, which is one of the node n1 lies in left and n2 lies to the right. So this should ideally be the LCA. The reason being, if I try to check, I will not find any other node which will be the lowest ancestor of both of them. Got it? So that is all about it. So basically we have divided into two parts. Are my recursion call. I am in my first call. First I will write the base case. Okay, for example, this is your LCA. You are passing root. You are passing n1 and n2. Okay, so base case is as usual. If it is null, root is null, then you are returning the null value. Return null. The other conditions are, I'll write the two conditions and third one will automatically fall into this scenario. So what are those? If n1 and n2 both are less than my root data, okay, then you recursively go and check for LCA of root dot left by making call to left side of root. Okay, in the other case, if both n1 and n2 are greater than my root data, then you go and recursively make call to the function for right side of the root. And the moment I will find one of the values being equal to n1 or means root value being equal to one of those n1 or n2, I'll return root. So this will hold true for the case when I would want to recursively make call for left and right part, and also when the diversion will happen, I will anyway return root for that particular recursive call that I will be making. Got it? So that is all about this problem. Now we will be coding it. So if you think about its time complexity, you will see that at max it's all about going maximum till the height of this binary tree. So big O of h is the time complexity, and the recursive stack is the only space that we will be using in this example. So if you have any doubts, you can ask me in the chat. Now we are going ahead and coding it. It's exactly what I have written, obviously in the better form. So let us start with it, starting off with the base case condition. If you have just a second, if root is null, return null. If n1 is less than root dot data. Cool. Okay, just then, and n2 is also less than root dot data. You recursively make call to root dot left and n1 and n2 as it is. Fine. Cool. If n1 is greater than root dot data and n2 is also greater than root dot data, you make recursive call to LCA for root dot right, correct, and make call to n1 and n2 as it is. In any of the cases, finally you return root. Also you have to make sure that you are returning the values that you're getting from there. Okay, return. Let's check. What's wrong? That is all about this problem, everyone. So in case you still have some doubts that how is this recursion solving our problem, I'll suggest you, if you have understood this much, go ahead and do one dry run on your own. Take an example and then, using the code in front of you, make a recursive stack, which we generally do in the questions I have taken yesterday also. Take a recursive stack, put the calls, insert the calls into the stack, remove them as and when you get a return value, and then you will realize final answer how you are generating from this particular code. Okay, so that's all about today, everyone. If there are no doubts, let's wrap it up. Okay, fine then, see you all in the next lecture. Bye bye and take care.